All right, so yesterday we filled out the table, right? The table represented G, okay? And what does G represent? G represents that guy right there, right? It represents the integral from -1 to x of f of t. And where is f? Where is f of t? The graph. The graph represents f of t, okay? So we filled out the table yesterday. So the table just pretty much represents a bunch of areas from -1 to that number. From -1 to -3, the area is 0. From -1 to -2, the area is 1, so on and so forth. Okay, so now, here we go. So now, this is what I was talking about yesterday. Now we have to figure out, so these questions you've seen before last semester. If I said that exact question, what are the intervals on which G is increasing or decreasing, justify? You've seen that question. You've seen it. You saw it last semester. We're seeing it again. That's why it's called the fundamental theorem of calculus, because it takes things we did first semester with derivatives and mixes it with what we're doing this semester with integrals. Okay? The two biggest things we cover in this class are derivatives and integrals, and it's a mixture of them. Okay? So, big question. Can't go anywhere else. Can't move any further unless we know this. How do we know when something is increasing or decreasing? How do we know when something is increasing or decreasing? Mm-hmm. No, close. You're very close. You're getting close. When do we know if a function is increasing or decreasing? What is the definition, or what is the justification that we talked about last semester? See what I made? Right? It's helpful. It's a little cheat sheet, right? I think we made one last semester. If you don't have one or you don't know where it is, but this is a question I've asked you last semester, so you should know. When is a function increasing or decreasing? Mm-hmm. No. When what is positive? The derivative, yeah. So anytime, it doesn't matter F, G, H, whatever letter they choose, it doesn't matter. When its derivative is positive, when its derivative is positive, we know it's increasing. That's the definition. When its derivative is negative, we know it's decreasing. That's going to be our justification. That right there will be our justification. Okay? All right, so now we have to figure out G prime. Where is G prime? What is G prime? Well, first of all, what's G? We can't figure out G prime unless we know G. What is G? Where is G, or what is G? Mm-hmm. Yeah, we just talked about it a few minutes ago. G is that guy. It's an integral, area under the curve. So what would G prime be? Think so? There you go, right? We've seen that before, right? G prime is the derivative of that guy, right? G prime is the derivative of that guy. It's like asking that question right there. Or asking that question right there, more closely to that guy. What is the derivative of that guy? Well, what did we end up getting? Itself, right? Just with an x instead of a g, all right? When we took the derivative here, didn't we just get 5x to the third power minus 4x plus 1, right? So it's the same thing. Because I'm telling you right now, you can write it down. This will be your FRQ for your test. this will be, they'll ask you about increasing, decreasing. They'll ask you about relative maximum, minimum. They'll ask you about um, concave up, concave down. They'll ask you about points of inflection. This is it. If I could show you the question, this is it, just with a different graph. That's it. They'll change the graph, but this is literally the question. Okay? But if you don't know how a function increases or decreases, then there's no chance, right? You have to know when does a function, what is the definition of a function increasing or decreasing? Okay, so we know g is the integral area under the curve for this guy. So what is g prime going to be? Okay. What is g double prime going to be? Okay. We don't need g double prime right now, but we will need it later. So we said when g prime is positive, that's when it's increasing. When g prime is negative, that's when it's decreasing. How do I know when g prime is going to be positive? How do I know when g prime is going to be positive? How do I know when this is going to be positive right here? These two guys right there. Maybe when the graph is above the x-axis. Yeah, because the graph is the same thing as the derivative. The graph is the same thing as the derivative. Here's the graph, here's the derivative. There's an equal sign in between them. They're the same thing. So in other words, you're just saying, when is the graph negative? When is the graph negative? Well, a graph is negative when it's below the x-axis. A graph is positive when it's above the x-axis. This is one of the hardest things students have in calculus, because that relationship between what is a derivative, what is the original, what do I look for, it's for some reason, it's very, very hard for students. But like I said, it's big on the test, on our tests and AP tests. Okay? So G prime or F, same thing, right? Is positive when it's above the x-axis, negative when it's below the x-axis. Okay? So here we go, increasing. It's increasing from -3 to -2. Because G prime is positive, or F is positive, either one, because they're the same thing. Okay. Decreasing. Well, from -2 to 0, at 0, it's 0. So it's not technically negative, it's 0. Or 0 to 3. Because G prime is negative. Okay. All right. Let's go to letter C. So letter C is I wrote the table again so you don't have to flip back and forth. So it's the same table. 0, 1, 0, 0, 1, 0. Negative 1, negative 1.5. Negative 3, negative 3.5. Okay. Now they're asking for concave up, concave down. Again, you've seen this question before. When is G concave up or concave down? What's the definition? What's the definition for when G is concave up or concave down? Mm-hmm. So G double prime is positive or negative, right? Okay. Well, what is G double prime? G double prime is the same thing as what? F prime. And what is F prime? First derivative of the graph. First derivative of the graph. What is that saying? What is that saying in plain English? What's another way of saying the first derivative of the graph? Instead of saying first derivative, is there another term I could use? Mm-hmm. Slopes. Slopes of that graph right there. Slopes of that graph. So we're looking for where the slopes are less than 0, negative, or where the slopes are greater than 0, positive. Okay, so let's go to the graph. Where is the slopes negative and where are the slopes positive? Well, if it's going downhill, slope is going to be negative. Going uphill, slopes are got to be positive. Okay. So, concave up, negative 1 to 0. Because G double prime is greater than 0. Concave down, negative 3 to negative 1. Zero to 3. Because G double prime is less than 0. Okay. Or in other words, the graph is going uphill or going downhill. Because G double prime is the same thing as the derivative of the graph. Derivative of the graph. Okay. So now, relative maximum, relative minimum. How do I know if something has a relative maximum or a relative minimum? What's the rules for that? What are the rules for if something has a relative maximum or relative minimum? Exactly. When the function changes sign, when its derivative changes signs, right? So when its derivative changes signs, we know we're going to have a relative maximum or a relative minimum, just depending on what we go from. So we're looking at G prime here, which is the same thing as F. when G prime or when F changes signs. How do we know that? How are we going to know that? How are we going to know when they change signs? When G prime or F changes sign. How are we going to know that?
Are we saying by the graph?
Could be by the graph, could be by the table.
Then it's when, that's when, how do I say this?
How are we going to know when either of those two guys changes signs? That's what I want you to think about. I'm not going to tell you the answer because you guys have done this before. How are we going to know when G prime or F, either one, doesn't matter which one because they're both the same, changes signs? Oh, when what crosses the x-axis? So
When F,
keep going. Pick up where you left off. He was going.
when F crosses the x-axis or somewhere close to that.
So G prime is the same as this graph here, right? So when this graph changes signs, that means it crosses the x-axis, right? So it changes signs here. And that's it, right? That's the only spot it changes signs. It changes from positive to negative here. Here it goes down. It doesn't change signs though, because it gets to 0. 0 isn't positive or negative. 0 is just 0. 0 doesn't have a positive or negative sign. So it doesn't change signs here. Okay. So -2 is going to be either a relative maximum or relative minimum. So relative, is it going to be a max or is it going to be a min? Because it's changing from positive to negative. And according to my definition, my little cheat sheet here, if it changes from positive to negative, it's a max. If it changes from negative to positive, it's a min. So it's going to be a max. Relative max at x equals -2 because G prime of x changes from positive to negative. It's important to note the change from positive to negative. Otherwise, we wouldn't know if it's a relative maximum or a relative minimum. We would just say it's one of the two. So there is no relative min. No relative min. Because there is no change from negative to positive, only from positive to negative. Okay, good. Letter D, inflection points. Inflection points. So inflection points refer to second derivatives. So we're looking for G double prime, which we know is the same thing as F prime. So what's the definition when the second derivative does what? We have an inflection point. Changes signs, right? So that's going to be our justification when G double prime changes signs. But now we have to actually find those points or point. So in other words, when f prime changes signs, how do I know when f prime changes signs? There you go, right? When the slope changes. When the slope of this guy changes. Right now it's negative, and then it changes to positive. So there is one right here. And then it goes positive, and then it changes one more time. There's another one right here. 2 spots. At 2 spots, it changes f prime or g double prime, changes signs. Okay, so those are both points of inflection. Okay, so we would say points of inflection at x equals -1 and x equals 0 because g double prime changes signs. G double prime changes signs. Done. Right there, what we just did is one of the hardest things for students to do in this class. And I think I know why. After 4, 5, 6 years teaching this, it's because you either have to know it or you don't know it. It's analyzation, it's analyzing. There's no calculating. There's no solving for x. There's no antiderivatives. You have to know it. You really have to know your derivatives, your antiderivatives, your integrals. What does an integral mean? What does this mean? And sometimes students think they know it, but they don't know it as well as they need to. So I'm telling you right now, literally, you can mark it down. Next week when we take the test, you will have one question on the on the free response that will be exactly like that. Some of you will take 10 minutes to do it because you're like, I know what I look for. Some of you will take the entire period. This shouldn't take you the entire period because you either know it or you don't know it. Okay? And that's what I'm saying right now to prepare you. Cheat sheets. I made little cheat sheets. That's helped me. It helped me remember because I have a lot of stuff that I have to memorize. Cheat sheets. Make those so you can kind of quiz yourself. How do I know if there's a relative maximum or minimum? How do I know if there's an inflection point? How do I know if any of those? Okay, you've done it before. We had these questions. Literally, we had these same questions last semester. Different scenario, but it's the same question. I didn't change the answer. The justifications are the same thing, right? Okay, last thing is the graph. Graph g of x. Graph g of x. How do I graph g of x? It's probably the easiest question you'll have all day.
G of x and the graph of that t are the same thing, I assume?
No.
Oh wait, no.
It's easier than you think.
Oh wait. No.
How do I graph g of x? I have the table, right? Don't I have dots? Just make dots. That's all you're doing. Make dots. We have the table, right? Make dots. The easiest question you'll have all day. G of x is the table. -3, 0. -2, 1. -1, 0. 0, -1. 1, -1.5. 2, -3. And 3, -5.5. And there you go. That's the graph of g of x. So if I was to find the derivative of that, it would be that graph right there. All right? You can check your answer. From -3 to -1, we should have a negative slope. Wait, we don't. Let's see. Oh, sorry, no. I'm referring to something different. Never mind.
From -3 to -2 should be a positive since it's a positive slope.
Oh, yeah. I see what you're saying. Yeah. Okay. All right. Okay, so now what I did was I put a bunch of questions on here. Similar, increasing, decreasing, points of inflection, horizontal tangents, 9 and 10. The heck are 9 and 10? So what I want you to do right now is do 7 and 8. Do 7 and 8, and I'll figure out what the heck's going on. So do 7 and 8. Okay, so number 7. On the interval -9 to 9, where is g increasing? Okay, so according to my cheat sheet, g is increasing when its derivative is positive. Okay, g's derivative is the same thing as f itself, and the graph is f. So in other words, you're just saying, where is the graph positive? It's positive from -9 to -5, and from -2 to +3, because that's where g prime is positive, because g prime is the same thing as f, which is the graph. Okay. Number 8. Determine all values of x, if any, where g has a point of inflection. Well, point of inflection, according to my cheat sheet, is when it's second derivative, when second derivative changes signs. When this guy changes signs right there. When f prime or g double prime. Well, if this is the graph of f, I'm looking for slopes. When are its slopes change signs? All right, well, positive slope, positive slope, positive slope, negative slope. So there's one spot. Negative slope, and then it changes to positive, and then it changes to negative. So there's another one there, and another one there. 3 spots where it changes signs. Okay. So points of inflection at x equals 1, x equals 3, and x equals 7, because g double prime changes signs. Okay. All right. Okay, so number 9. Number 9 and number 10, they ask you similar questions, but they don't give you a graph. They give you the actual function. Instead of giving you a graph, they give you the actual function. 2t to the 4th minus 8t to the 3rd minus 24t squared. We do the same thing. So this is one we haven't talked about yet today. We've talked about it before in the past. When does something have a horizontal tangent line? When does anything have a horizontal tangent line? How do we know if where something has a horizontal tangent line? I think you've literally had this question on a test before.
When f prime equals 0.
Mm-hmm. When f prime or g prime or its derivative equals 0. So we're using f. So when f prime equals 0. Okay, so how do we find f prime? I know f. How do I find f prime? Or what is f prime going to be equal to, I should say? Mm-hmm. If you didn't know that, you could spend the time finding the antiderivative, plugging in x, plugging in -1, subtracting, and then finding the derivative, but you would end up with this guy right here. Right? We did that earlier yesterday. Here. Right? It's the same thing. It's the second derivative, the second part of the fundamental theorem. Okay? So figure out when that guy equals 0. So let's set it equal to 0. Let's see, GCF is x squared, 2x squared. So I get x squared minus 4x minus 12. So when you factor that, it's going to be x minus 6 and x plus 2. Because they got to multiply to be -12 and add to be -4. Set everything equal to 0. Solve for x. Yeah. Horizontal tangent lines. At x equals 0, x equals 6, and x equals -2, because f prime of x equals 0. Okay? I want you to do number 10 now. Do number 10 right below it. Okay, so I know a function is decreasing when its derivative is less than 0. Okay, so I found the derivative, set it equal to 0. I know it equals 0 at 0, -18, and 3. When do I know how do I know it's negative? What do I have to do next? First derivative test. First derivative test, we've done that before. -18, 0, 3. Plug in values in between those to figure out where it's increasing, where it's decreasing. Where the first derivative is increasing and decreasing. So if I plug in something less than -18, it's going to be negative there, and negative there. So it's going to be negative times a negative times a negative, which makes a negative. If I plug in something in between 0 and -18, it's going to be positive here, negative here, and negative here. So positive here, negative here, negative here. So negative times a positive times a negative makes a positive. If I plug in something between 0 and 3, 1, 2, whatever, it's going to be positive here, negative here, positive here. So positive times a negative makes a negative. And then if I plug in something bigger than 3, 4, 5, 10, 100, whatever you want, it's going to be positive here, and positive here. Okay. So decreasing from negative infinity to negative 18, or 0 to 3, because f prime of x is less than 0. Any number you plug in for x that's less than negative 18 or in between 0 and 3 is going to give you a decreasing function. Okay? All right. I want you to do now 11 and 12. 11 and 12. Again, similar problems, they're just changing it a little bit, tweaking it a little bit. See if you understand what they're asking. Number 11, g of 5. So you just plug in 5 everywhere you see an x. So really all they're asking you is find the area from 3 to 5. So the area from 3 to 5 is a triangle. It's going to be negative since it's underneath the x-axis. Negative 3. Okay. The next one is the second derivative. Okay. Well, the first derivative is equal to g of x. So that means the second derivative has to be equal to g prime of x. So in other words, they're saying, where is g prime of x? Negative 2. Or what is, I should say, that's what they're asking. Well, f double prime is the same thing as g prime. So what is g prime of 2? Negative 2. What is it asking for at g prime of negative 2? What is the question asking? Either one of these will give me the right answer. So whichever one you want to solve. F double prime of negative 2 or g prime of negative 2. What is that question asking? They're both asking the same question. Both of these guys are asking the same question. So pick one that's easier. F double prime or g prime. What is that saying? What is that question asking? So if I was just asking what is g of 2, let's ask an easier question. If I was asking what is g of negative 2, what is that asking? What is g of negative 2?
0.
0, right? It's just asking for the y value. Okay. Then what is g prime asking? If that's asking for the y value, what is g prime asking? For the slope at negative 2. Good. So the slope of negative 2. So negative 2 is a part of this guy right here, right? This guy, it's right here. But its slope is the same from negative 6 to 0, right? So we just have to find the slope of that segment. Let's see. 1, 2, 1, 2. So down 2 over 2. Slope is negative 1. Same answer for both. Same answer for both. Negative 1. So either one is okay. Okay. All right. Let's see. So tomorrow what we're going to do, we'll stop there because I think the rest of it will take longer, is similar stuff. Equation of the tangent line. Equation of the tangent line. What is the maximum minimum value? What is the, or that one, you've seen it before. That guy you've seen before. So 16 is the same thing as what we just did. F double prime of 1. What's the slope at 1? Right? Okay, so we'll finish that tomorrow, and then I'll give you some time to work on the assignment tomorrow. Do some practice on your own.